Oh no, look, someone is stealing the most expensive vase in the museum.
But how will we catch them?
Don't worry. We can use fingerprinting evidence to catch them. And using these surfaces, which we will talk about later. So, welcome to DNA fingerprinting. Our big question was, which hard surface provides the clearest fingerprint image using black fingerprinting powder?
I'm Carson Richards.
I'm Chandler Davey.
And I'm Shivani. And so, before we get into this investigation, we need to figure out what steps we're going to take. So, what are fingerprints? We're going to look at fingerprinting. We're going to look at how to read fingerprints. We're going to take a look at our scientist's hypothesis, finally the experiment, and then we're going to analyze our data and finally wrap it up. Exciting. So, our first few surfaces were this plastic, which is shown on the very left, this glass, which is a little bit different than the one we used, but it was a little bit hard to see, so we chose this one. And then we used stainless steel, as well as canvas. And then we also used the door frame here and the tile floor of the room.
Alrighty, so what exactly are fingerprints? Fingerprints have provided key evidence in countless cases of serious crime and are virtually the most important piece of evidence that can be obtained from any crime scene. Each fingerprint is unique to each individual and are therefore a very key piece of evidence in determining a certain suspect. A fingerprint is formed when the pad of one's finger comes in contact with any surface. And in order to obtain these prints, we need to know what type of prints we will be obtaining. There are three types of prints that can be obtained. The first is a plastic print. A plastic print is a print that is imprinted into a very soft, malleable material such as silly putty. These prints are the easiest to be collected and can just be taken in on the material into a forensics lab and can be further analyzed from there.
So the next type of fingerprint we have is called patent, which basically is a visible fingerprint in the form of something the suspect left behind, such as blood. And these types of fingerprints can be photographed very easily.
And then finally, latent fingerprints, and basically these are the exact opposite of patent fingerprints. You can't see them, they're invisible to the naked eye, and they're very fragile, so it requires some sort of reveal, like dusting or chemical usage.
Now into the fingerprinting process itself. Fingerprinting is a scientific process that allows researchers to obtain a fingerprint from any given surface. And through the fingerprinting method, there are 20 different methods that can be effectively used worldwide in order to obtain the latent, patent, and plastic prints. And once these fingerprints are obtained, they are stored in what is called the IAFIS, which stands for the Integrated Automated Fingerprint Identification System. This system is a digitalized system that stores all the fingerprints taken across the world, and these fingerprints can be compared to one another and further analyzed in any circumstance needed.
So there are three different patterns of fingerprint that a fingerprint can have that we will be going over. The first is a loop, which is basically like a small circle or arc that just connects back to its starting point.
The second is a whorl, not a whirl, but a whorl, and basically it just looks like a spiral shape.
And lastly, we have the arc pattern. The arc pattern is exactly what the name implies. It starts at one end, reaches its peak, and then gradually decreases towards the other side of the print.
Alright, so, like I said, our scientists have told us that they think the clearest fingerprints will come from non-textured surfaces that are also dry. Got it? Alright, let's get into it. So, this would be glass and plastic.
Alright, so for our experiment, we were going to test different surfaces for fingerprinting. These surfaces would be the canvas, door frame, glass, plastic, stainless steel, and the tile floor. Then we would apply the black fingerprinting powder, which is basically a very fine powder, and we would apply this to each surface with a fine brush. Then we would brush off the excess, so only the fingerprint is left, or only the fingerprint covered with the fingerprinting powder is left. Then we would remove it with a clear tape and transfer it to a piece of paper for evidence.
Just like Carson mentioned, we used black fingerprinting powder. When you use a powder like this is called the dusting method, and it is used to obtain Latin prints. This process is very tedious, but we decided to use this process in our experiment because we wanted to obtain Latin prints, as they are usually the most common print found at a crime scene. Once we obtained these prints, it was important that we analyze them all on the same grading scale. In order to do this, we created a grading scale that is very similar to the FBI's grading scale of fingerprints. Our grading scale consisted of 3 different categories. The first category was the contrast between the print itself and the background of excess powder. The second category was the amount of distortion the fingerprint held. Was the outline clear, or was it kind of misshaped? And lastly, the clarity of the pattern. Was the pattern identifiable, or would it take a little bit more analysis to come to a conclusion on what type of pattern the print held?
Alright, so firstly we have canvas, and for our contrast you can see that it contrasts very well. You can see the black fingerprinting powder very clearly, but there doesn't seem to be any actual fingerprint, so we gave the distortion quality a 1, as well as the pattern quality, because there's nothing observable here. And so that averaged out to a 3.3.
So our next surface was the door frame, which had a contrast of 8. As you can see, there's black lines and ridges, but there's also a contrast between that and the background of white. The distortion, we gave it a 7 because it wasn't very distorted. You can see the outline pretty well. And then the pattern quality, we gave it a 6 because it's overall easy to see and you can tell that it's a fingerprint. So this would average out to a 7.
Our third experiment was done on a glass surface. So far, this was our best result. The contrast between the print itself and the background was very clear, as we can easily see the print and the background was fairly white. Secondly, there was very little to no distortion. There was a clear, defined edge around the entirety of the print. And lastly, the pattern quality was super clear on this print as well. We could easily identify that both of these prints had an arc pattern. However, we knocked a few points off in this category because there were some missing ridges in the transferring process, as you can see right there. So, that said, this print averaged out to a score of an 8.5.
Next is plastic, which would be this right here. And we said that the contrast was a 4 because you can see it pretty clearly, but it's still a little bit murky. And then the distortion, we gave that a 2 because it's not very great. And then the pattern quality, as you can see, you can't see the ridges very well. There's not a lot of distinct patterns, so we gave that a 2. And that averaged out to a 2.67.
Alright, so next up we have stainless steel, which we gave a contrast of 6. It was very contrasted because the fingerprint was dark and the background was light. Distortion, we gave it a 7.5 because, as you can see, there's a very fine outline around the edge. And then pattern quality is 7.5, so this would average out to a 7.
Our sixth and final experiment was done on the tile floor. This was a very poor quality print that we obtained. There was very little contrast, although we could see that this area was a little darker because this is where the fingerprint powder was, but the majority of it blended in with the surrounding background. The distortion on this was very high as well because there was no specific outline that we could really see. And lastly, the pattern quality, we rated a 1 because there is, well, no pattern there that we could easily identify. For those reasons, we gave this print an average score of 2.67. After gathering all of the prints from each of the 6 surfaces, we rated them in order from best to worst. Best being over here and worst over there. First off, we determined that glass was the best surface, following stainless steel, next the door frame, then plastic, the tile floor, and lastly the canvas. A commonality between the top 3 surfaces was that they were all taken from a relatively smooth surface, in comparison to the last 3, which were all taken from a textured surface and its surface that absorbed the powder, which made the powder a little bit harder to remove, and which primarily caused the lack of contrast between the print itself and the background.
So all of our top 3 surfaces in our hypothesis were smooth, non-textured, and dry, which means our hypothesis was correct. So some of the errors in our experiment were that there were inconsistencies both from person to person and just when we were brushing each fingerprint, some of the fingerprint could have been removed. There's also a lack of oil on our hands, which caused some of the fingerprints to show better than others, and later fingerprints just didn't show up as well because there wasn't as much oil left. So how could we have improved? Well, we could have used lotion to simulate natural oils and sweat, and we also could have just done more research on the fingerprinting process in general.
And so, in our thrilling investigation, we explained how we used plastic, patent, and latent fingerprints, loops, whorls, and arcs. And finally, we described the method we used, which was using fingerprinting powder, the brush, and our different surfaces. Now, the big reveal. Who is our criminal? Carson? It's you? Oh my... It's Carson! Here's our references. Thank you for listening.